right? So basically, all these folks had months to patch those systems, and they didn't do it. And then the third one, and I do not like to call out vendors because, you know, for the most part, I actually think Microsoft does a very good job with security. You know, a lot of this has to do with legacy Windows stuff and then people's behavior around Windows. But, you know, should we be using Windows in our IoT implementation? And I think that's a fair question to ask when we're building an IoT solution because, you know, of the broad use of Windows and what the potential impact can be. So now if we generalize those three themes, the first is identity and access management and credentials are very important in IoT, very important. So we're going to spend some time on that. Updating software, I'll probably mention this like 6 times in this presentation. Updating software is absolutely critical, right? I mean, you have unmanned devices. There's no one sitting there clicking yes, you know, let's reboot, right? It's your job as the administrator of this system to worry about that. And then kind of if we generalize the Windows thing, let's think about protocol and third-party support. You know, little more in the details. There's a protocol in Windows called SMB, which was used part of this attack. You know, should that have been turned off? You know, on some of these systems. But we should think about the protocols we're using. We should think about the third-party software that we're using in our IoT implementation. All right, so this is kind of just setting the framework. Here are the 4 things we're going to talk about today. So the first is securing the device. Okay, so as I like to say, the things, right? That puts the T in IoT, so we should have a lot of focus there. We'll spend a majority of our time there. We also want to talk about essentially, you know, what code should you write and what code should others write, right? So we want to think about those boundaries and maybe have some guidelines there. We want to think about operating at IoT scale. We'll talk about why, you know, what does scale have to do with security? And then, you know, finally, kind of some miscellaneous things, security throughout the application stack. And again, you know, all these things are really based on practical things that I've learned over the past many years. You know, some things probably are pretty basic and some are advanced. So if you're a security practitioner, but the thing is, they're basic things that a lot of people missed, right? In all these companies, I'm sure there are a lot of smart people who are smart at security and they made some very fundamental mistakes. And, you know, we just want to review them so we don't make those same mistakes, not to really, you know, cast aspersions on them. Okay, so from securing the device, you know, why is IoT security different? So we got a couple of things to think about with IoT security, and I think this helps us get in the mindset of what we need to do when we build the architecture. We're going to talk about some IoT protocols, so we'll give a little bit of, not security talk, but a little bit about IoT protocols, and then get into the security implications there. Talk about device identity, layering security, bootstrapping trust in the device, and then whitelisting. Okay, so all good things. You know, most of these are very applicable even outside of IoT security, but you know, certainly important in IoT security. Okay, so why is IoT security important? Why is it different? So, you know, from a customer standpoint, we want to think from 2 different standpoints. 1, you're the vendor, you are building an IoT product, or 2, you're the customer, you're consuming that product. And from a customer point of view, you know, my background is really in industrial IoT, so, but a lot of it's applicable to consumers as well. But, you know, if you're making a buying decision, for instance, for a company on behalf of, you know, industrial thing, you certainly want to think kind of from both point of views. Okay, so from a customer point of view, and imagine you are procuring smart televisions for your boardroom or maybe for your house, right? So you're buying smart television, and you cannot control devices that operate in your environment, right? So basically, you're somewhat at the mercy of that smart television manufacturer, right? So something to be concerned about. You cannot patch or alter the device without help from the vendor. How many folks here have applied patches to their smart television in their home? Okay, how many folks, oh, you have, good for you. How many folks here think that there may be some vulnerabilities in their smart television? Okay, so, you know, so just think about that one. And, you know, it's not just smart TVs, but it's other things as well. There is a threat to your environment from vendors who do not operate at your security standards, right? So sometimes you may be buying a consumer product, you know, maybe they don't think about security at all. Or even if you're buying a commercial product, you know, how much time do you think the projector manufacturers in this room think about security? Now, you know, is it connected to your network? I don't know. But, you know, how about your copier manufacturer, right? Or any of those things that are going inside your environment. And your security posture may be higher, except that there are a bunch of things you have to worry about for vendors that are not doing a great job. Okay, so from a vendor point of view, you switch hats. Okay, you can't control the environment for which the device operates, right? So the vendor says, do not put this device on the internet. Do not put it on the internet. And what does someone do? They put it on the internet. Okay, so the vendor's exposed in the sense that, imagine it's a big brand name vendor. If something bad happens because of it, it's going to say XYZ Corp has been compromised, or their device was compromised, not the idiot in IT put it on the internet when it wasn't supposed to. Okay, you cannot mitigate security issues in the environment without help from the customer. Let's say you push out a patch. Let's say by default you have default update to your device and you push out a patch, but the customer blocks it, right? Or the customer turns it off or something. That's it's your problem, but yet you're not in control. And there's a threat to your brand from customers who do not operate at your security level. So those are the things to think about, kind of customer view and vendor view. Now, kind of part two, what are some other things that we want to think about? Well, there's a very long device life cycle for many devices. So a lot of times, consumer devices, they're throwaway. They expect you're going to refresh them every couple of years. So maybe the concern's not there. But imagine you're building an MRI machine, or you're building an ATM machine, or you're building a piece of a tractor trailer, or some big piece of equipment. You have a very long device life cycle. Think about all the software in the supply chain for that device. What do you think the chances are that all that software is going to be supported 10, 15 years down the line? Okay. There's going to be mixed operating systems and protocols, right? So basically, you may say, we're standardizing on this protocol and this operating system in 2017. A couple of years from now, a new protocol comes out that's better, or a new operating system comes out that's better. Or you acquire another company and they have different OSs and different protocols, right? You are almost necessarily going to be supporting a mixed environment. You won't have a uniform set of OSs and protocols. And then, we also want to think from a generic computing platform versus a purpose-built one. From a generic platform standpoint, right? If you have a Windows laptop, you can put certain security controls on that device, right? But if you have some sort of, if you have this projector, that's probably not running an endpoint security piece of software on there. So the types of things that you're going to have to do to mitigate risk are quite different. All right, so now we're going to step back for 2 slides, really just talking about what certain things are, just so we can understand and think about the security implications. So first, let's think about short haul communication. And short haul communication is anything that's happening towards the edge. So imagine there's a device there. That device may be communicating with a sensor or actuator, right? Or the sensor or actuator may actually be on the device, either way. And it may be communicating with a gateway. You might be thinking, well, my IoT implementation doesn't have a gateway. And if that's the case, then your device is your gateway, right? So that device is the thing that's talking up to the cloud or up to the data center. Okay, so that's short haul communication, things that are going on between the sensor/actuator, device, and gateway. Okay, so now from a long haul communication standpoint, things that are crossing networks, going to the cloud, to your data center, somewhere else, that's long haul communication. All right, so some example short haul communications, Bluetooth, Zigbee, Wi-Fi Direct, those are some wireless ones. We have Modbus, which is really more of a LAN type protocol for OT type network. Okay, in general, short haul protocols, security is challenging. And if you don't believe me, think about all the Bluetooth exploits that there have been. Think about some of the issues with Modbus and some of these other protocols, right? So basically, those protocols seems to always be an issue with those protocols. Always an update. Good chance if you're using Bluetooth and the device is several years old, it's probably not on Bluetooth 4.2, probably an older version. Good chance there's an exploit that someone could attack. All right, so on the long haul front, a bunch of different protocols, MQTT, CoAP, HTTPS, WebSockets, right? So those are some example protocols. And from a security standpoint, certainly better, but IoT standards are a work in progress. And if you don't believe me, who thinks MQTT is the security standard for IoT? No one? All right, I've read a whole bunch of things that say that's the case. But You know, from an MQTT standpoint, a couple things to point out. The payload is still undefined. And so let's talk about what that means. Let's say we're defining communication, and I say, you know, two humans, we're going to communicate, and we're going to use a language as our communication mechanism, okay? So that's like MQTT. But the payload is, I'm speaking in English, and you're speaking in Chinese, or Spanish, or some other language, right? So basically, the payload is undefined for most of these protocols. The standards are a work in progress. So on that one, don't believe me there, Google AWS IoT MQTT. Okay, you're going to find a web page on AWS IoT that has about 10 to a dozen different exceptions to the MQTT standard. Okay, so to think that we are, you know, we are in a place where standards are still emerging and things have not really settled. Now, when you think about, you know, certain things, how has other communication gotten better, like HTTPS, right? That's something that evolved over time and is really kind of hardened with use and, you know, and everyone adopting it. That has not been the case with these other protocols. So I'm not saying don't use them. What I'm saying is don't think that we're done there. And, you know, certainly that can have security implications. So, you know, some things to think about with protocols. We want to make sure protocols have been rigorously security tested. Okay, so if it's a kind of a standard, an industry standard, we're probably fine. If it's a custom protocol, so if you're using a vendor custom protocol, maybe fine. You know, I would ask the vendor, where's the security report for that protocol? Have they done any sort of security evaluation there? Because that's certainly something to think about. You know, you could imagine all sorts of nasty things hiding in there. Okay, so encryption is a must. Everyone probably said, Rob, of course encryption is a must. You know, why are you even saying that? You must have mitigating controls if the short haul protocol does not support encryption. You know, Modbus, which we just gave the example on the last slide, that's an example where Modbus doesn't support encryption. You got to use it in conjunction, like with TCP/IP. So, you know, so really things to think about. Don't just assume just because a protocol exists, oh, everything's going to be fine. You should really check. I mean, it doesn't take a lot of checking, but you know, you should really make sure that that's the case. You want to use the latest patch version of the protocol, and you need the ability to update protocols. So I said I mentioned update a lot of times. You need the ability to update protocols, especially short haul protocols, and you want to think about updating both sides, right? When's the last time you updated your USB headset? You know, for Bluetooth, right? Or I don't know if you use a USB headset, but I'm sorry, a Bluetooth headset. But you know, but basically, if you don't update those protocols, you know, the device side may be vulnerable, or one side may be vulnerable. All right, these are all the things that vendors don't. So I have a kind of a vendor agnostic view. These are things that vendors don't, you know, want to talk about because it's not exciting. They don't have a product to solve it, right? This is just kind of like hard work for the implementer. All right. So from a device identity standpoint, you need the ability for establishing identity of the device. Okay, so you can see that robot, he has his ID card. That's obviously how you know what the device is. And you want it to provide an identity assertion and an authentication mechanism. And you know, obviously, there's no human interaction in that authentication. So you know, of course, there are options for device identity, right? So basically, you could use a public key certificate type solution, right? So this is just like a certificate on your website. You have a public key and a private key. You publish the public key, and that's known to everyone. And then you have a private key only known to the device, and that's a secret. Okay, and then and that can do encryption. And you know, how does that work? It uses very hard one-way math. The way to think about it is, imagine you have two very big prime numbers, right? You can multiply those two prime numbers together very easily, but you can't factor that resultant very easily, right? Unless if you know what those prime numbers are, you wouldn't be able to do it. So this is based on really hard one-way math. You have a public key and a private key. You know, pretty well understood thing. Anytime you go to a website and you see that little, you know, green bar at the top saying that you're using their certificate, you know that's the case. Shared secret methodology, similar concept, except for the fact that both parties know the secret. All right, so both parties know the secret. And so basically you have the secret on one side and secret on the other side. That certainly has some security implications. All right, so now, if we go look at device identity for IoT, what are some of the challenges? Certificate management is very challenging, right? It's very challenging. There are a whole bunch of vendors that provide it. They're expensive, they're complicated. No one likes managing keys. A little bit more so for devices, right? You're gonna have to proactively do that remotely. If anything ever got messed up, then someone has to go on the device itself. And then one other thing to think about is how far through your system is that identity maintained, right? So if you have a certificate on the device, and is it used just to send the payload across the internet and then terminate there and then decrypt, and then that whatever data was associated with that device identity, is that gone? Or do you maintain that relationship on the server side? And there are pluses and minuses both ways, but just something to think about, because if you maintain it, it's complicated, but you basically set up your identity scheme one time and you preserve that relationship throughout your system. If you don't maintain it and just say, okay, it's in this blob of data, someone can run analytics or do something and query across all that data. Maybe that's the desire of your project, but maybe you really wanted a separate identity scheme for data coming off different devices. Right, on the shared secret side, still need to manage those keys. Obviously, compromise of a secret, when two people know a secret, it's easier to compromise it, right? So imagine you have your administrator of your IoT system logged onto the server, has access to all the shared secrets there from all, a million devices out there, logs on, downloads all the secrets, sticks them on his USB key, and walks out the door the next day. Okay, so now all of a sudden, all of your devices, the secrets are compromised, right? And you have to reseed. What's that?
That's not the way you would use a secret in Azure, though, right?
That is not the way you would. Okay, so that's not the way you would use the secret in Azure. Totally agree with you. I'm not saying that as a recommended practice. What I'm saying is you want to make sure you are avoiding that kind of behavior, because there are plenty of cases. When you think about it, does your administrator have to know the secret that's on the device? And the answer probably is yes, right? They may know it, unless if you're doing something on the server side to mitigate, to keep the controls there.
The thing where you ask the server has the secret stored away, and then you ask it to use the secret to do some operation.
So if you have if you have it stored in a hardware module, you're absolutely right. You could do it that way. Guess what? Everyone does not do that. Okay, so you're absolutely right. Are there controls you can put in place to avoid that problem? Yes, you can. I would say that's not necessarily the industry norm, right? So, my goal here is to raise awareness so that we all think about these things and then do them across the board. Again, all these things that I'm telling you, or almost all of them, are things I have observed someone doing. Okay, so this is pretty practical, or know of. Okay, so some example IoT implementations. AWS IoT uses the public key, a certificate methodology. One interesting fun fact: what is the expiration time for the AWS IoT certificates? That's just a guess. What's that?
3 years.
3 years. That's like a typical website certificate. That's a great guess. Any other takers? It's a little higher.
35 years.
Yeah, never. So they avoid the certificate management problem by never expiring their certificate. So as I said, certificate management is a challenge. Now they're not, they're exposing this information and they want other vendors to come in to help manage that. So they're not behaving irresponsibly. But you think about the challenge. If that certificate expires, that device is dead to the server. Someone has to physically go there to reseed it. Okay, so that's just one of the challenges with IoT, and one of the things to think about are, when do your credentials expire and how do you expire them? Okay, so a more common one is just use a shared secret between the platform and the device. Again, that also has some fundamental challenges with it as well. Okay, so I do not think we're at the state of the art for device identity today. Or how about this? It's unlikely that device identity today will be the same as it is 5 years from now. I'm not discouraging us from not using these methodologies today, What I'm saying is we should keep them in mind as we build architectures going forward. Okay. You know, and again, third-party certificate and key management software exists to help solve these problems. All right, so now, from a layering security standpoint, so we saw some challenges for our implementation. You know, what are some of the things that we can do? Well, we can layer security. We can manage our device credentials. You know, so basically we could tie the credentials to device characteristics. There are a number of vendors that are doing that, basically looking at, you know, maybe the clock speed of the chip or, you know, some profile of the hardware to measure that. That increases the insurance that the credentials have not been compromised, right? Because let's say someone had that secret that was being used, but it did not match the clock speed on the device. You know that maybe there's been a compromise. It allows you to manage the lifecycle of the credentials. And, you know, one example technology is device authority. Not endorsing them, just saying, you know, this is the type of vendor that's out there. There's some other ones as well. Okay. Some other methodologies are real-time threat detection. So from a real-time threat detection, you want to use machine learning basically to detect and mitigate threats. You know, a bunch of vendors out there doing that today, based on past known patterns of behavior and threat intelligence. So basically, you know, looking for actually data in the ecosystem to be able to apply that to say, oh, this is talking to a command and control server, something's going on that's bad. It would be great if the risk model was tied to IoT data. So these top two things are a bunch of vendors that do that. Risk model tied to IoT data, I think there's a more limited set of vendors. One example here is Security of Things. And, you know, again, I'm not advocating for any particular vendor, just, you know, showing that there are vendors out there to help solve some of these problems. All right, so now bootstrapping trust in the device. Again, I'm only telling you things that are actual practical things that may have happened in the past. So Lenovo, okay, again, I said I don't want to call out vendors, but this is a fun one. Okay, so I'm calling them out, but that's not a nice thing for me to do. A number of years ago, like 3 years ago or so, I think 2014, they shipped their laptops with an advertising piece of software called Superfish, okay? And this thing was gonna be great. It's gonna give you all the pertinent advertising based on your web browsing. And they shipped it with the self-signed cert, not necessarily a bad thing, but they used the exact same private key for thousands and thousands and thousands of laptops. So if you use the exact same private key, guess what? You get one laptop, you can compromise the traffic for everyone else's laptop. So, you know, really fun problem. They shipped basically with malware. And I believe this put Superfish out of business. They were, you know, kind of an advertising company. But, you know, what did Lenovo not do? They did not bootstrap trust in the device, right? They did not diversify their keys for each laptop. So, yeah, so here's the lesson learned. Every device must have a diversified key from every other device. That's like an absolute must, okay? Absolute must. You know, whether it's a private key, a shared secret, or an inferred key, you absolutely have to have it. It has to be different from every other device, or you're making a really bad mistake, okay? And you need to be able to have a scripted process to do this at IoT scale. If you're relying on Ralph every time something ships to, you know, type in a different secret in there, that's not going to work well, right? It needs to happen at the time of either manufacturing or provisioning. Okay, not picking on Ralph. Okay, so you know, some other things. When we secure a device, you should really whitelist IP addresses. So you think about our device right now. We just, you know, created this device. It can talk to every single server endpoint in the whole wide world, right? If we whitelist it and say you're only allowed to talk to, you know, this IP address or this DNS name or this set of IP addresses, we're significantly reducing our attack surface for that device. So you know, things like this is a great control to help to reduce the attack profile of our IoT implementation. All right, so now we talked about a lot of stuff on the device side. I told you there were 4 parts. Device side was the lion's share of it. We want to use security-proven protocols. We want strong device identity, including provisioning. And we want to do whitelist-approved servers for communication. Yes, sir?
Just curious why you don't have whitelist, what executables can run on it.
So I think, you know, so that would be good too. You from a device standpoint, so didn't really dig into like the innards of the device. There's all sorts of things we want to do in the innards of the device. I think whitelisting what applications are running is a good one. Again, this is a question of is it a general purpose computing platform or is it a specific device? If it's a specific device, you're probably just shipping the software that's on it. Like you don't go in and install software on your ATM machine, as a for instance.
No, but a router or something.
Right, so absolutely. I think that's a great control. I think the thing about IP addresses though is you have a whole wide world, right? And if you think about some of the other attacks, so I didn't mention them because try not to keep this talk too long. But if you think some of the other attacks, basically it's internet access to those devices, right? As opposed to if it had a restricted list, it would make it less likely to have a big problem. Okay, all right. So now next one is we're going to talk about how much code should you write. You being your organization, doesn't have to literally be you. Okay, I'll make an assertion. The less code you write, the fewer vulnerabilities you will have, and there's a probably there because obviously if you wrote real tight code that was hard to maintain, you could introduce vulnerabilities, you could do all sorts of things. Don't put error checking in. I guess that's less code, but then that opens yourself up to other vulnerabilities. So for the most part, minimizing the code that you're writing is going to help. Got to do that smartly. Okay. But what we want to do when we don't write the code is we want to use well-vetted third-party platforms and software, okay? And you really should be focused on developing functionality that is core to your value proposition. So if you are, if you're a trucking company, right, should you be writing communication software? Should you be writing administrative screens? Or should you be writing software about your trucks and packages and carriers that are very, proprietary to your knowledge, to your business, okay? So focus on developing functionality that's tied to your core competency. Don't write communications infrastructure, scale infrastructure, security infrastructure, device management software. Okay. You want to, when you do use those third-party softwares, please validate them. Okay. And we need to update third-party software frequently. I believe that's the 4th time I mentioned it. Very important. Okay. So choose your third-party software carefully. So when we think about different types of software, we have open source and commercial, okay? And then I kind of created this broad versus niche, and you can imagine, so what's a broad open source, software? Maybe like top-level Apache projects, common Linux distributions, OpenSSL, right? So those are all very broad. It's like everyone uses them, right? So those broad ones, they get high level of attention from large commercial vendors and government. Okay, that was not the case 2 or 3 years ago, much more so now. Okay, so you get free testing, right? So if you're going to use broad open source software, that's probably a good thing. If you're using broad commercial software, typically well tested with a strong security culture. Certainly there's some caveats for certain vendors, but for the most part, you're going to get some of those things. You should still validate with the broad vendors, but probably you're in a good spot. Okay. For the niche ones, you just want to think about, what are we doing? So from a commercial perspective, security depends on the company. Vetting is important. I have an example of a niche vendor on the next slide, which I think is very strong security controls in place. And then, niche open source, my recommendation is either don't use it, or if you do use niche open source, plan on spending resources on the project. It's not free. So basically plan on testing the code and committing fixes to the open source project. Because from an open source perspective, some of these niche projects, it's like one person developing this project. They're probably not doing extensive security testing. So they may have some very valuable code, but it's really incumbent on you to make sure that code is well security tested. Okay, we want to pay special attention to crypto libraries. Okay, so number of times non-security companies should write cryptographic functions. Any guesses? 0. Oh, okay, good. So we'll go to the whiteboard. We'll write it out. Right, 0. We really shouldn't be doing this. I don't think this is the trend now, but a lot of times, and most developers now, they just want to stay away from writing anything having to do with crypto. Let's leave that to the specialists. Very important. So easy to make mistakes. So easy to make mistakes that have broad implications. Okay. So we want to use well-vetted third-party library. So open source vendor, OpenSSL we talked about, and then the commercial vendor I was talking about, Wolf SSL. I think Wolf SSL is a great example for IoT, just because they have a strong crypto library. It's tested by all sorts of third parties, and they have a very small footprint. So if you're writing, I do not work for Wolf SSL. I have no commission check up from them, but they do have a very small profile. So very good for IoT devices. Okay, make sure to update to the latest version, and then one other thing: you don't get a jail free card if you're using a third party vendor. If they're using crypto libraries, find out what they're using. Right? If it's something you've never heard of, or if you Google it and you have heard of it and there's a whole bunch of red things next to it, you should ask your vendor about that. All right, so operating at IoT scale. Trim this section down because I'm running short on time. Okay, so what does scale have to do with IoT security? Scale and security actually go hand in hand. A system that does not operate at scale is susceptible to a denial of service attack. Security functions that do not operate at scale are not secure. And multi-tenant IoT applications have special considerations. Okay, so those first 2 points, a little bit light here. If you're interested in more details, I have them. I cut that from the presentation. On the multi-tenant one, how do you make certain that one customer's device does not show up on another customer's IoT implementation? This is a little bit harder than you might think. And you say, well, you just have a code, and that code's tied to this customer. But the guy who's installing it's installing it for multiple customers, and they put the wrong code in, and oops, and now my proprietary data is on there, right? So there's just things to think about in terms of actual multi-tenant wise. How do we make sure that our devices don't show up on another customer's implementation? What data is shared between systems? Is reference data shared between systems? Does your reference data have, is there data leakage tied to your reference data? Do you have a special site, black site 123, and now all of a sudden shows up in someone else's system? If a customer engages in heavy use of a system, how is that going to impact your availability to the system, for you to use? And are all administrative functions fully separated, right? So can I go on, log in as administrator, administer all of my things, not touch or affect anyone else? Or the person's doing it on behalf of me, can we make sure that they don't mess up my stuff? All right, so security throughout the application stack, handling cryptographic materials, updating software firmware and configuration, and threat modeling. So just like the gopher, remember the gopher's really good at keeping a secret. Have you ever heard a gopher spill a secret? Never, okay? We want to do the same thing. We want to make sure for secrets, encrypted storage, encrypted transport, we have a good initial seeding process. We have good algorithms. How many parties know the secret? Someone leaves your company. This is the classic one. Someone leaves your company. Which secret do they know? Which ones do they have electronically? Or do you use IoT Project 1 as your secret? For all of your devices, right? So how many parties know that? Can it be distributed at IoT scale? So if you're doing this for hundreds of thousands of devices, can you do that, or tens of thousands of devices? Do you do periodic secret rotation? We talked about the AWS IoT implementation. Do you have a plan for rotating your secrets? And then what's your process for handling a secret compromise? Because it very well could happen. All right, so now what's your time to remediate? So let's think about, something bad happens, what do we have to do? We receive a vulnerability report. It's internal, external, whatever. We need to diagnose the issue. Is this really an issue? We need to create the code fix, okay? We need to test the code fix, and we need to distribute the code fix. Okay, so this process is pretty long for most companies, right? But now, you have 10,000 devices out there with some bad vulnerability. What's your ability to close that? What if the vulnerability report is some sort of public thing that's happened, right? So test automation is critical for being able to effectively meet a deadline. You need to be able to run thousands of tests quickly. Absolutely critical. Just in general for security, but especially when you have all these devices out there. You need a distribution mechanism for updating the software, right? If you can't distribute your patch, that's a big problem. You cannot trust someone's going to run around with the USB stick updating all those devices. All right, so according to the IoT Security Guide, If you don't have a plan for patching or deploy IoT devices, then you shouldn't deploy them in the first place. So I think this was the 5th time I said that, but super, super important. I mean, you really should not do the deployment in the first place. I mean, other than maybe a little pilot where you physically have access to those devices. Definitely, putting yourself at risk. Okay, so last thing we want to cover, security thought starts with a threat model. If you don't believe me, Microsoft Azure tells us security starts with a threat model. And the first page of their Internet of Things security architecture diagram, security starts with a threat model. What is the threat model? That's a good question. It's a method for analyzing security of an application. You want to decompose the application, you want to determine and rank threats, and you want to determine your countermeasures and mitigation. And then, why is this good? Because you get a reduced cost of fixing vulnerabilities after the product ships, you prioritize your risk mitigation investment, and you can minimize your exposure to risk. So lots of good things for doing a threat model. Figuring out how you can pull your product apart and how the bad guys can look at your product. All right, so we talked about securing the device, how much code you should write, operating at IoT scale, and then security throughout the application stack. All right, so that was just a brief glance at some of the things to think about for IoT security. I actually have a longer deck, believe it or not. If you want a complimentary copy of our IoT security checklist, shoot me an email. It's right there. And I'm happy to send you guys that. If you need help with your IoT project, please give us a call. Questions?
Other questions?
We unfortunately don't have a microphone tonight, so raise your, yes, all right.
From a policy perspective, with IoT products, whose responsibility is it to embed security early on in the process of development? Is it the government, is it consumers, or is it companies?
Yep, so IoT has a shared security model. So that may not be comforting to say or hear, but when you think about it, just go for the device, think about all the things in that device. You have physical threats, you have firmware level threats, right? You have chip level threats, you have software, and then you go all the way through the stack, protocol, server side. How many vendors are in your server side implementation? A lot. So it's a shared security model. We as consumers, and I say consumers meaning enterprise consumers, have a responsibility to ask those questions of our vendors, and I really believe that. I think expecting government action, it is going to be so difficult to police. It's going to be very difficult to police IoT security from a government standpoint. I think we as a community need to say, hey, this is very important. And really take the shared security model to heart, that everyone in there, even think about it, if you as a user use a poor password and the system gets compromised that way, right? You have a shared role in that. Yes, sir.
What are your observations in terms of device technology and battery life?
Yeah.
But the more you ask an endpoint to do in terms of security, encryption and layered security and keys and hard math.
Yeah.
Is that draining the battery?
Yeah. So that's a great point. So I guess a couple things. So depends on different type of devices. From a battery standpoint, there's some chips that can do crypto at a lower battery expense. Those devices that are out there that are battery powered, you should expect they have a finite life associated with them. Also, you want to think about mitigations. If it's a battery powered device, mitigations outside of just at the device level, right? So I'm assuming a battery device is probably talking over the cellular network to your data center. So what sorts of things can you do at the data center level? Maybe as the data comes in to say, is this good? Should I really be sending that command out to that device?
Excellent.
Yeah.
All right, thanks for that.
Other questions?
One right here.
Yes.
How does the consumer?
Yeah.
What are the reporting criteria for consumers? How do you describe so that you are taken seriously even by the manufacturer?
So I think, I think on the consumer side, it's very difficult as an individual to be taken seriously by the manufacturer because, let's say, you're buying your device for $200. I mean, if they don't get this, you don't get the sale, the manufacturer doesn't care. Now, Consumer Reports evidently is going to be doing some cybersecurity stuff. Paul talked about how he met with UL,
Underwriters Lab.
Underwriters Lab, thanks. At one of the conferences, they have a very interesting cybersecurity standard, has not been adopted yet. But if we as consumers collectively say, I need the UL cybersecurity certificate, that certainly would be a step in the right direction. Just like today, we would not tolerate if our toaster lit our house on fire. We all want UL for power. Should be the same thing. I think we're years away from that, frankly. For me personally, people are like, "Oh, you're so into IoT, you must have everything in your house must be IoT." I'm like, no, I'm so into IoT, I have nothing IoT in my house.
Yes. My most recent purchase, actually, for each of our cars is just an old-fashioned road atlas, right? Because, GPS, maybe it's there, maybe it's not there. But road atlas, that's a good buy. Yes.
You mentioned about the IoT standards work in progress.
Yeah.
What do you see as a timeline for the standard to come up? Early standard.
I don't. Yeah.
Need more and more assurance that if I'm putting my device into their house, they're secure.
Yeah, so for consumer, I can imagine standards evolve. So there's like the Apple HomeKit, and there's some other standards that are. You can imagine a player like Amazon or Apple or Google kind of driving everyone one way. So I can imagine on the consumer front. When you think about IoT, it's a market of markets, right? So you have healthcare, and you have, let's say, industrial automation, and you have all these different transportation. You have all these different industries. To think that there's going to be a standard across all of them, it's possible. Just it's hard for me to envision that. The needs are so different, and if you also think about, let's say a small cellular device that has a very bandwidth constrained capability versus a big piece of machinery where bandwidth is, or processing power not an issue. Difficult for me to believe that there will be a standard. I can imagine, a whole set of standards, but I think we're years away because it's not like, with MQTT, people I think have falsely claimed that one. But I think we'll see different standards emerge. Hopefully some vendors will work together to make that a reality, but we have not seen that yet.
I'll use an example from recent, which is the Devil's Ivy vulnerability that Senrio revealed. This is in a library called GSOAP. It's kind of an open source SOAP library that's used, I guess, across like millions of devices, like 30,000 downloads a month from their GitHub repository, incredibly, or SourceForge, I can't remember what it is. They found a, no authentication remote code execution vulnerability in GSOAP, right? Which there's a company that maintains GSOAP and sells, I think, a commercial version of it. They're very responsive, they patch it and so on. But kind of the chain of custody breaks down after that. So you've got a patch for GSOAP, but GSOAP doesn't have a way, obviously, of pushing that out to all the devices that have used a GSOAP library. And my sense, I don't know about you, is companies may be using it in their product and not even be aware of it. That was a decision that was made at the developer level, maybe, about using that library or not.
So they could be using it.
Yeah.
It could be inside a library that they're using. I mean, it's very difficult to know. So the industry in general has moved toward knowing what software is in your stack now. So
software build of materials.
Software build of materials. But any software that's been out there for a while probably doesn't have a good one. There's probably stuff that's there. That's
why Partly was so hard.
Right.
Because everyone had OpenSSL somewhere they didn't know where it was.
Right. So you sort of said, well, you got to be really careful about what third-party software components you use. That's simple sounding, but in practice, really difficult. I mean, it's clearly.
The reason I put it out is because it's difficult.
Yeah, right. So you can look and say, okay, there's one guy in Finland who's maintaining this library. As you said, this person may not have time to really go deep on security because he's just trying to stay on top of the feature requests and the bugs. But in this case, you've got pretty mature looking, got a company behind it. They're updating it. But of course, it's got a vulnerability in it because all code does. Is there, from a management sort of software building materials level, how do you think companies are going to get a piece of that?
Let's say you actually knew that GSOAP was in there.
Yeah, right.
You could look at the version number and say, oh, this is an old version.
Right.
But yeah, I think the state of the art today
yes.
is not sufficient to protect against bad guys.
And what about these companies like Black Duck or
those are great. Yeah,
Sonatype, I think is the other one.
Exactly. Yeah.
Right. So
I mean, that's a great thing to do on your software to do code scans. Those things are not infallible though, but certainly it's going to help mitigate.
Okay.
It's going to help mitigate risk. I mean, in general though.
I'm not getting paid by either of those companies though.
No, yeah.
No
just in general, you're not. It's a difficult problem. If you do have that bill of materials, you're one step forward though, right? So basically, once you have that built, you could probably see, once you have it, you probably see that there are half a dozen pieces of software that need updating. So start there and get the stuff that you know. And
like you said, just having that software building materials, that's the minority of companies that are at that level of maturity, right? It's like the crawl, walk, run.
Correct.
Like that's a walk or even a run, and most companies are.
Yeah, that's a walk.
Yeah, that's a walk. Right? But most companies are still trying to roll over onto their back. Right.
Unfortunately,
it's child development. Yes, and then Jen in the back. Okay, go. Yes, you sir.
Yeah, I just want to learn about which are the agencies in the US who certify the security aspect of IoT devices.
Yeah, so Underwriter Labs is one. There's some other ones. So basically, there's zero traction, and with the zero traction. I don't know what's gonna, maybe that is a place for government action. I do feel like sometimes government gets the ball rolling though, and it could have unintended consequences that are not ideal. But there's really no traction right now. I mean, if I were to put money on one, I would say Underwriter Labs, but that would probably be, still slightly long odds.
And I think Linux Foundation just acquired or merged with what's Craig Spiesel's OpenSoft. What is it? Open Online Trust Alliance. I think they're looking at stuff like that. And then there's one that Pete Zayko is doing, Mudge, and I'm not.
Yeah, which is the slide UL.
So no, I think Underwriters Lab lawyers didn't like that. But something it basically is sort of like that, yeah. But as Rob said, there's not critical mass. Underwriters Lab. If you got an electrical device, you send it to them. There's not that standard yet. There's not that.
I think that's a very difficult position for commercial and enterprise to certify a device because we discover new vulnerabilities all the time. So let's say they say that today this device is absolutely fine against the known vulnerabilities.
But
So what I'm talking about is that in terms of liability, hey, you said that this is device is secure. I don't think there is truly a company or any certification or any testing I can do.
The thing I like about the UL one is its expiration is very short, so that's one thing. Secondly, they have a lot of controls. You really need to know exactly what software is in there. You do fuzz testing. There's a whole bunch of controls that you have to do. My guess is if you pass all those tests, your product is toward the peak of secure. I totally agree with you. Vulnerabilities are going to come out, but if you don't start somewhere, what other choice do we have? And I do think it's a great starting point, but the bar is very high.
I agree, and what I was trying to say is that all we need to do is the assurance of that this device was built in a secure manner, and they have all the controls, many controls in place, but they can never certify it.
Well, so certification just means that they have all those controls in place. It's not a guarantee. Right?
Hold
on, let me just answer your question. You asked a question about the cybersecurity books. No, who was that? Was that you? No, someone over here. No?
Yes.
That was you. Oh, okay. Just read a really good book, How to Measure Anything in Cybersecurity Risk. Changed my life. Been looking for a quantitative methodology for doing risk assessments.
And on the device management thing, I mean, I think one model that we can all relate to is sort of the iOS versus the Android model, right? So how many of you guys are iPhone users, right? Okay, so latest version of iOS is 10.3.3. My guess is most of you guys have already upgraded to 10.3.3 because like Apple pushed it out to you. I don't even know what the latest version of Android is. My guess is most of you are not running it, right? Because between, well, maybe you are. Between Google's latest version of Android and your device, there's a handset maker, there's a carrier, right? Each of those has to, you know, modify and adapt that, put their own junkware on it, whatever. And the result is, generally, it just doesn't get to you. You know, 70 or 80% of Android users are 1 or 2 versions behind. Some of them are a lot more than that. And the model that's developed is basically like, well, if you want an Android upgrade, just change your phone, right? Just we'll sell you a new phone that'll have the latest version on it, or maybe it won't. And that's kind of a cautionary tale, I think, for IoT, right? Which is what we want is iOS. Maybe without the vendor lock-in that you get with iOS. Right.
And 60% active Android.
Right. Thanks for coming. Right. Yes.
I mean, this is something that Google is working on. So Android O has a hardware abstraction layer that's basically designed so that so that you can upgrade everything except designated machine-dependent parts. And well, if you've got one of the Google phones that are running Android O right now,
yes,
this may help you in the future.
Right. Right.
Everyone else is out of luck.
Right. Right. So down the road, maybe. One thing I will say also, I read it was in one of my newsletter updates. I think the last one that went out. Mark Clayton, he's at markclayton.github.io, just did a teardown of he bought a home security system, Honeywell, and he's a security guy. So he did a teardown of it, like, oh, cool, I bought this new home security system, let's figure out what's in it. And he basically wrote the whole process out. It's on his blog. It's exactly what Rob is talking about, the process by which he figures out what OS this is running, what open source components are in it, extracts the firmware from the device, creates an environment so that he can then kind of emulate and fuzz and test that for exploitable vulnerabilities. And it pulls together a lot of the types of things. So if you want to know, like, well, how would a hacker go at a run-of-the-mill home, connected home security system? It's a very good kind of 2,000-word walkthrough of like all the different steps he took. And yeah, so it's worth reading just to get a sense of like, oh yeah, here's how that mindset and that set of eyes looks at a connected product.
What's the name you mentioned?
It's Mark Clayton, M-A-R-K Clayton, C-L-A-Y-T-O-N, .github.io. And I think it's called, it was in, if you get my weekly ledger, if you're one of my subscribers, it's down in the like security news from around the web. It's called Reverse Engine. You can also probably Google Reverse Engineering My Home Security System. And it's, yeah, markclayton.github.io. It's a really pretty technical, but well-documented teardown. He doesn't get into fuzzing it and finding vulnerabilities. It's just sort of like kind of out of the box, how do you figure out what software components make up your connected device and what the provenance of this is, because most of these are not created from whole cloth within the company. And that's basically what he finds is like, oh, they grabbed this, open kind of, maybe it was open source at one point, or maybe it was Honeywell, but they had an open source repository. I mean, it's like, it's definitely very funky provenance. And also from a device maker standpoint, it's really interesting because in this case, it may be that there was one employee who kind of went off reservation and took maybe some proprietary code, but was hosting it in a way that it got, indexed and exposed in a public way. It's kind of like when it really wasn't open source. But it's very interesting. It's worth thinking about and reading to sort of be like, wow, we need to think holistically about, if we're going to develop this product, about what's going into it, what we want, if we're using open source, what our exposure is there, if we're using proprietary software, how to keep it from inadvertently becoming open source, and those types of issues. Because obviously, from an attacker standpoint, the more information they can get, whether that's administrator credentials, whether it's information on, the functioning of, proprietary code or what have you, the more powerful they are. So anyway, I thought, as you were going through it, I was like, oh, this reminds me so much of that teardown I was writing. Okay. Are there other questions, comments for Rob?
Thank you.
Thank you.
Thank you.
Great presentation. Jen has a special offer, right?
Yeah, sure. So Rack 7 has a customer experience conference that we put on. It's in Boston.
It's called Unite.
It's on the 13th and 14th of September, so really soon. And we will be running an IoT lab for people who want to come and have a go and try to have a hacking some stuff. The people running it will be Craig Smith, who runs the Black Hat and DEFCON that I talked about earlier, and Daryl Highland, who runs our IoT practice. They're both really, really great IoT hackers. If anyone is interested in coming, if you have business card off me and email me, I can give you a code for a free pass. So you can just come and check it out and see if you're interested. There's no pressure, like, yes, it's a custom conference, so some of the talks will be very much about our products and that kind of stuff. But the IoT stuff is not at all, and you can just come check it out.
The conference is called Unite, and it's down at the Seaport again?
Seaport, World
Yep.
Trade Center in the Seaport area.
September 13th and 14th.
It's a nice event.
It's a great event.
Very friendly crowd.
So next month, I mentioned the Devil's Ivy vulnerability. Margaret is coming back from Senrio, who is the researcher who discovered that vulnerability, and she's going to give us a rundown of Devil's Ivy. Okay? So definitely put it on your calendar for next month. Yes?
Paul, a question for you. I saw that you are live streaming and everything else. So for us who are newbies, how to get hold of the slides and all the materials?
Once I click stop, it will get sucked up into the YouTube, and as soon as they've crunched it and it's public, I will post it on the Meetup. I'll post a link to it on the Meetup. Okay?
Great.
Thank you so much.
Thank you very much for the presentation. My pleasure. I just want to give my card.